Solving linear absolute value inequalities. An absolute value inequality is an inequality in which some variable expression appears inside absolute value symbols. For the case that we have the absolute value, the x, or the expression in x less than a, it's equivalent to the compound statement that negative a is less than x less than a, which means x greater than negative a, and at the same time x is less than a, or we say both statements are true at the same time. Another case, absolute value the x or the absolute value the expression in x greater than a is equivalent to the statement x less than negative a or x greater than a. Let's see examples. For this example, we're going to solve the absolute value inequalities and describe the solution set using the interval notation and by graphing. In part A, we have 2 times the absolute value of x plus 5 strictly less than 12. Your goal is to solve for x. X is in the absolute value symbol. We're going to work on peel off one layer at a time by dividing both sides with the value 2. The value 2 is positive, so the inequality symbol does not change. It remains as it is, which is strictly less than 12 divided by 2 is 6. And after that, we have absolute value of the expression x plus 5 less than or strictly less than. The less than means we're going to have the compound inequality as x plus 5 in the middle, greater than negative 6, less than positive 6. Convert it into the compound statement, and then we're going to solve for x as what we did in the earlier examples. Next, we're going to subtract 5, both sides, all three parts of the inequality. We get x in the middle. On the left-hand side, we have negative 11. The right-hand side, we have positive 1. At this step, we are done solving this absolute value inequality. For the graphical way to represent the solution, negative 11, positive 1, strictly greater than negative 11, strictly less than positive 1. Empty circles at both numbers and then join them together with the line. So this is the graphical way. And for the interval notation, we're gonna follow similar way. Empty circle means not including, open parentheses, same as at 1. Next example, we have the absolute value of the x minus 2 greater than or equal to 5. This time we have the greater symbol. So we're going to break it up into 2 inequalities. The first one is x minus 2 greater than or equal to 5. Another one, join with the term or, x minus 2 less than or equal to opposite side of the right number, which is negative 5. Now we have 2 inequalities to solve for x. The left-hand side one, just add 2 both sides of the inequality. Then we got x greater than or equal to 7 as one solution set. And the other one, join with the or. Same way, we're going to add 2 both sides of the inequality. Then we get x on the left less than or equal to negative 3 as another solution. So we're going to use the graph to represent the solution set. So negative 3 on the left of the value 7, x greater than, that means the arrow pointing to the right side of the 7, including, so solid circle here. Negative 3, similar way, solid and pointing to the left because we use a number that less than or equal to negative 3. The graphing is done. So the next part gonna be the interval notation to represent this solution set starting with -3, including with square bracket any number lower -infinity, close the parentheses, or we join with the union set. This one is union. And then the group, another group of the solution. At 7, we include the square bracket. Anything greater, use the notation positive infinity, and then open the parentheses. So we got the interval notation to represent this set of solutions. For this example, we have 7 minus absolute value of y over 2 plus 3 greater than or equal to 12. Solve for y, so we're gonna leave the expression containing y in there. So then by subtracting 7 both sides of the inequality to get negative absolute value of y over 2 plus 3 greater than or equal to 5, and then divide all by -1, or you can multiply by -1, it doesn't matter. When you divide or multiply by the negative number, the inequality symbol will switch to opposite. At this step, we're gonna get absolute value of y over 2 plus 3 less than or equal to -5, which is not true because the absolute value by definition is the magnitude or the distance from the quantity to the origin point or the 0 point. So then whatever the number that comes out from the equation inside of the parenthesis or in the inside of the absolute value is gonna be always like non-negative number. So then it's not true that gonna have the result as -5. Therefore, in this case, we said there is no solution. If no solution, we can write it as the empty set or the null set symbol, or the open and closed set symbol with no member in there.